we are group 7 and the problem set that is assigned to us is to design a more state machine that will detect the sequence 1010. This is the state diagram of our machine. So we start with state 0 with the reset, and then we move to state 1, 2, 3, and 4. This is the VHDL code from the machine. So we have clock, reset, and X as inputs and C as an output. And we create a data type and the signal of the current state and the next state, and we assign the type to them. And we have two processes in this code. So the first process is to know when to trigger the transition in state. So the first case is when the reset is 1, because reset is active high, and when the reset is active, whatever state it is, it will be forced to become to state 0 or to become the initial state. And when clock is 0 and clock event means that when it is at the falling edge of the clock, the current state will transition to the next state. For the second process is to decide what will be the next state to transition to. So for example, if we are at state 0, if the egg is 0, then it will be from state 0 to state 0, or that means there will be no change in state. If we are at x equal 1, then it means that state 0 will transition to state 1, and so on for the other 3 or 4 states. This is the test bench for our sequence detector 1010. So we define the clock period to be 20 nanoseconds. We create the clock process is where the clock toggle between 0 and 1 each half period, and we have the reset so that the value we can set the initial condition at the start of the simulation for one clock period. And to start the test case, when we start the simulation, we wait for 2 clock period for the reset to do its job. And then the first one is we are testing for 10101010. So our expected value should be 00010101. So we will have x equal 1, and then wait for clock period, and then x0 clock period, 1 clock period, 01010. And for the next test case, we wait to clock period to separate them. And for the second half of the test case, we are doing everything except for the 1010. So the expected output should all be 0. So we have 0011101110. Now let's take a look at the waveform. Let's say run the simulation for 400 nanoseconds and take a look at the waveform. We can see that okay, we have x as our input to be 1 0. Oh no, we have the reset at the beginning, and then we have x as 1010, and that's when we see our output become 1. So we have 3 1010 1010 and 1010 for 1 2 3. And for the second half of the input, uh, we test everything that is not 1010, so our output is always zeros. And that is all from our